Hi, I'm Venkat Giri, CTO at KFintech. KFintech is a leading financial technology provider in India, offering registry, transfer agency, and investor services solutions across asset classes. We build digital financial services that demand high scalability, resilience, and data consistency. We were scaling rapidly across region and our legacy relational database could not keep up with our need for availability, scale out, architecture, and low latency access across zones. We needed something cloud native that preserved PostgreSQL compatibility without giving up on consistency or performance. We evaluated other distributed systems, but Yogabyte stood out for its PostgreSQL compatibility, scale, performance, and strong consistency model, and availability to scale horizontally with zero downtime. It gave us the best SQL and cloud native architecture. Also, the active deployment across the region was critical for us. We run Yogabyte DB on-prem in multi-AZ setup across Hyderabad data center. Our distributor super app is a complex read workload which is designed to transform how mutual fund and NPS distributors manage their operations. It provides a comprehensive suite of features to efficiently handle business hierarchies spanning employees, sub-brokers, service managers, and investors under unified account. We also appreciate its integration with Spark, Prometheus, and our Node.js and .NET ecosystem. We have achieved significant improvement in the application latency, near zero time during upgrades, and seamless node AZ failure that directly translate to better customer experience and trust. We have also future proofed Yogabyte, allowing us to innovate without re architecting our stack.
Hi, hello everyone. I am Kirtideep and I work at KFin Technologies as data platform leader and architect. It's an honor to be part of DSS conference along with the fellow technologists and leaders. Today, I'm excited to walk you through our journey of leveraging YugabyteDB to support our highly transactional mission critical workloads and how we approached scaling, performance, and operational resilience in a regulated and a very high availability environment. So, about KFin Technologies. KFin Technologies power India's capital market ecosystem by delivering robust operations and advanced technology solutions to leading financial institutions. So our mission critical platforms which support a wide spectrum of services from mutual funds, alternate investment funds, national pension systems, wealth management platforms, insurance, IPOs, and more. So we enable real-time decision making through our proprietary data lakes, dashboards, and rich analytic platforms, which provide actionable intelligence to our business users. Today, we are the number one corporate registrar in India, servicing nearly 50% of the total market. We proudly support 26 out of total 51 Indian mutual fund asset management companies and are recognized as the number one registrar and transfer agency in Southeast Asia. We are also the second largest central record keeping agency for the national pension system in India with over 1.6 million pension subscribers. We manage more than 330 million investor folios, making us the largest in India by volume and reach. So let me now introduce you to a powerful platform which we have built, which is a distributed super app. So this application is designed to fundamentally transform how mutual fund and NPS distributors manage their operations in today's fast world and digital first environment. At its core, this app offers a comprehensive and integrated suite of features built with one clear goal, which is to simplify and streamline how the distributor workflows work while enhancing the visibility and control across the business. So this app allows distributors to manage employees, sub-brokers, service managers, and investors all within a single unified view. Whether it's onboarding a new sub-agent, tracking investor transactions, analyzing performance metrics, or ensuring compliance, everything can be done with this app. The two in a real time and with minimal manual intervention, which is the key. So, in an essence, I could say that this super app is not just a product, it's a scalable digital ecosystem that empowers distributor to focus on growth, relationships, and investor trust while we take care of the technology behind the scenes. At KFin Technologies, one of our key objectives was to deliver a wide range of always on services to our customers. Services that must operate at massive scale and with uncompromising reliability. However, as our platform grew and transaction volumes increased, we encountered several critical challenges that demanded immediate attention. First, there was the issue with scale. So, during peak traffic surges, like high transaction cycle days or quarter end closures, we faced performance bottlenecks that had critical applications to go down, which led to direct and negative impact on user experience. This was not acceptable for any mission critical platform. And the second one is we were facing operational complexity because our systems were spread across multiple databases and servers, and each one needed separate patching, upgrades, external monitoring, which made the management difficult. This setup sometimes caused delays, issues directly that affected our users. And third, the perhaps most critical, I would say, was concern around resilience. Our traditional single primary architecture couldn't assure that we have zero data loss, especially under high volume conditions. It also lacked active availability, which meant planned maintenance or unplanned failovers would inevitably cause some downtime, something which we simply could not afford. So these challenges collectively became a strong driver for us for this architectural transformation, pushing us to rethink how we design for scale, simplicity, and resilience going forward. As we looked ahead to modernizing our platform, we laid out clear set of expectations, things that were non-negotiable for our future architecture. So the first one being scalability. The platform must scale seamlessly, both horizontally and vertically, to meet increasing business demands, data volumes, and user concurrency without any major redesign. So we have seen in the past how the data sizes and the volumes has grown rapidly in past few years, and we are very confident that this business is going to grow significantly, and the sizes, volumes, and the expectation from the user on the response times are going to be very critical, and we want to design our future data platform to meet that scale. So the next is the deployment flexibility. We wanted an hybrid architecture. Basically, we do not want to get locked in with any particular cloud vendor or on only running on premises. We want the flexibility where we could run in on premises or on a single cloud or on multiple cloud or a combination of on premises and multiple clouds. So the next critical factor that we wanted to consider was the people. We have our existing people who are knowledgeable and talented on existing technologies. So we do not want to pick something very new that people will struggle, and there'll be a lot of learning curve is going to make things very slower and harder for progress. So we wanted something where the learning curve is minimal, with minimal training required. They can use their existing skill sets and build from there. We do not want a complete new technology to be learned. That's going to kill a lot of time. And the other important thing is the security. So we are a regulated entity, and we go through several audits over a year, and we have the top auditors who visit us and grill us through various evidences, understand our processes. So it was paramount for us to have our platform meet this enterprise grade security standards. We wanted the system to have built-in role-based access controls, encryption both in transit and at rest, audit logging features, and seamless integration with our existing enterprise security ecosystem, which we already have. All this while with all this in place, we still want to have our regulatory requirements fulfilled with the product itself, not by using any additional external tools. And finally, another important consideration we had was vendor independence and portability. Although we are confident about building the new system the right way, however, we wanted to look from a long-term perspective, because there can be situations or use cases where the companies can be acquired by other companies. Change in leadership may change in the direction of the company, so we do not want to get logged in with any one particular vendor. So if at all there is a case, we wanted to be able to quickly move out of the existing system, and that will help us mitigate any challenges that we may have in future. So let me walk you through our earlier setup, starting with the database and infrastructure landscape that we had. So we had multiple OLTP databases which were running on independent high performance on-premise servers. So these servers were very well configured, but they came with typical limitations of vertical scaling, which meant that as the demand grew, scaling beyond a point became very difficult, and that was too expensive. So, in terms of the technology stack, our data processing relied heavily on ETL pipeline that were built using stored procedures, along with technologies we use like .NET, SSIS packages, and Node.js. When we looked at the database load patterns, we observed that we had about 60 to 70% of operations which were read heavy, while 30 to 40% were writes. One of the operational constraints we faced was that our applications worked on slightly outdated data, which limited our ability to make real-time decisions, especially in areas like customer servicing and reporting. So all these factors collectively signaled that we needed a more scalable, flexible, and real-time capable platform as our business continued to grow very fast. So this is the typical architecture diagram that I want to walk you through how we have built this new data platform. So on the left you see there are multiple servers which are the source servers where the transactions originate, which are the OLTP database servers. We have multiple such database servers where the transactions are loaded to, and we have enabled change data capture, which are going to track the changes and writes to the transaction log. And we used AWS services, one of the service being AWS DMS service, which is going to connect to the source and read these transaction logs, and then takes all the changes for the respective tables of our interest and loads them to S3 in CSV format. So in these S3 files, there will be every row, and every change to that row is being logged, and it is tagged with the respective command that it belongs to. For example, if it's an insert, update, or a delete command. So once we have the data that is available in our S3, then we have our AWS EMR service that's going to go and read these S3 files, and then it does some transformation and consolidation, and then loads it into a mirror layer. From the mirror layer, the data is then moved and transformed and converted and put it into data mart. From the data mart, we have EMR cluster which runs Spark cluster, which runs and pushes the data to Yugabyte, which is hosted on our on-premises data center. And we have applications which are available on AWS, which are going to consume this data and display or provide dashboards and insights to the end users. So we have another pipeline as well in addition to the AWS pipeline, which is built on .NET. So we have a .NET application which is going to connect to the sources and then writes the data to the on-prem Yugabyte database. The reason we have two pipelines is the AWS pipeline needed to handle large volumes of transformation and creation of data marts, while the second pipeline, which is on .NET based application, it is just simple select from multiple sources and write to the target Yugabyte. So we do not want that additional complexity of or requirement for AWS service to handle that kind of a use case. So we just went ahead with .NET for that simple use case, and we also avoid that additional layer of moving data from on-premises to cloud and then from cloud to on-premises. So now we have directly on-premises to on-premises. So a little bit more about the cluster of Yugabyte that we have. So we have total of 6 nodes, each one with 32 vCPU. So 6 into 32 vCPU comes to around 192 vCPU. And these servers are VM based servers which are based on Hyper-V technology. And the typical the topology that we have is a single region, which is an on-premises data center. And at the moment, the kind of read and writes that we see in our Yugabyte cluster is we have about 10K IOPS for reads and 40K IOPS for writes. The reason for high writes is because there are many sources from where we collect the data in batches, and then we push those batches in bulk at a periodical intervals. So we have bursts of writes that happen. That is the reason why we see a high number of write operations. And as I explained, like the data is being moved from either from the cloud or from the .NET application is in batches. So we tested with various different batches of different sizes, and we found that the optimal size for the data load to Yugabyte is around 300 in a batch. So we have batched around 300 upsert commands which are going to be pushed onto the Yugabyte database. And since this is a batch processing, we are going to capture a bunch of a lot of user uh, transactions grouped together and then loaded into the Yugabyte, which means we had to open multiple concurrent connections and write the data at same time concurrently. So as of today, we see that at maximum we spin up to 1,000 concurrent connections, both from together from EMR and the .NET application, which are going to establish up to 1,000 connections and parallelly going to hit 300 batch each connection, and they're going to hit the 6 node Yugabyte cluster. And the cluster the smart driver provided by Yugabyte is going to take care how the requests are sent across 6 nodes for load balancing, so that there is no dependency or bottleneck on a single node and there is no impact on the performance. So although we are doing such high number of writes, our applications which are consuming this data are never affected, and that is the beauty of this architecture. Both read and write heavy workloads work together seamlessly without any user impact. So that is pretty much I wanted to briefly and at a very high level explain about our architecture. So now let's talk about the impact of our transformation and how we address the key challenges that we faced earlier. So first, in terms of scale, which was the most important, we saw a significant improvement by distributing both read and write workloads across multiple nodes. We were able to eliminate the bottlenecks of a single primary server architectures. So our response time obviously dropped from seconds to milliseconds, which enabled a far smoother and faster user experience. So the next challenge that we handled was the operational complexity. So the new platform, to our surprise, even though it was a distributed setup, we thought it would be more complex to handle the setup, upgrade, and configuration. But to our surprise, it was pretty straightforward. So we had a YBA controller node, which is where we download the software and then we install the software on the YBA platform at the beginning, which will provide us with an UI from where we can continue the rest of the setup process. So from the YBA controller, we can push the installation to all rest of the nodes, whether it can be 3 nodes, 6 nodes, how many ever. There is a bit of configuration that need to be done in the YBA platform, but it's all straightforward. There's nothing additional complexity or anything. And even it is so seamless that if there were any failures, we can just retry, even if a simple failure could be retried, and the process will continue from where it failed, not from the beginning. So that was simply awesome. And once we have the initial setup configurations everything done, we had received periodic minor version upgrades that we wanted to apply. So we took the support of the Yugabyte support team for initial minor version upgrade, and we understood the process, and it was straightforward, similar to that how we were set up initially. First upgrade the YBA control plane, and then from UI you continue to push to the remaining nodes. And any subsequent minor version upgrade, we even did not need Yugabyte support because we were very confident and we were able to handle because it is very simple. And in addition, one of the most liked things I had was the built-in features it had in the YBA platform. So the backups doesn't need any additional external tools or anything. It is integrated to the YBA platform. So we can simply configure the backups, full incrementals, point in time recovery, the rollbacks, recovery, everything can be done through YBA platform. And this platform also has built-in alerts and observability. So we have a lot of alerts where we have configured to receive emails, and the metrics that we have part of the platform has been simply awesome for initial troubleshootings. So we were able to monitor the usage of the number of concurrent connections, the number of operations, the resource usage, which can be CPU, memory, disk IO. Then we have available health checks where which tells based on some 15 to 16 health check parameters the health of the cluster. And then we have additional metrics available for T server, master server. There are processes which need to be understood for distributed architecture. And so yeah, basically it provides a lot of features within itself. You really don't need any external tool. At least I do not see any purpose or requirements to get additional external tools and integrate with Yugabyte to monitor or get alerts or to understand the performance metrics. This made our management, and it has reduced significantly our operational overhead. So the next, when it comes to resilience, uh, the results were very good. Even when we had 1 or 2 nodes which went down, there was no disruption to our applications because the remaining nodes were able to seamlessly take over these uh, connections, and then they were able to serve the application. There was no impact or any issues reported by any applications while we have done many planned maintenances. So one of the most important aspect for any project is the cost. And what we have noticed is we have a significant reduction in total cost of ownership, which is achieved by moving away from the legacy databases, which were per core expensive licensing costs, which we had to pay. And then we were able to deploy the Yugabyte on our existing on-prem infrastructure itself, which reduced a lot of cloud cost. and we were not only able to improve the performance and scalability that we achieved through this platform, but we did it with a better cost efficiency. That was the best point. So, as part of our journey, we developed a deep understanding of distributed database internals, especially on how Yugabyte works under the hood, which includes concepts like tablet leaders, graph consensus protocol, data sharding, smart driver, to name few. So, this knowledge has helped us in designing the right data model in such a way that it aligns closely with the Yugabyte DB's architecture, ensuring optimal performance, scalability, and fault tolerance right from the beginning. So we also executed both one-time and continuous data migration strategies seamlessly, moving workloads into Yugabyte without disrupting ongoing business. We had few learnings there where we had to identify what is the ideal batch size, what is the best primary key, and what's the best shard key. So these were key for ensuring we get the best performance for our data loads and reads. And next is to ensure smooth application connectivity, we had used Yugabyte Smart Driver. So it is one of the best things which was provided by Yugabyte, because you don't need any external connection pooler or load balancer. The system, if you just use the Yugabyte Smart Driver, it takes care of routing your connection to the respective nodes. You don't have to worry about connecting to a particular node from different applications. You just simply use Yugabyte Smart Driver. You can simply use any one IP address, or you create a DNS name, or you create a virtual load balancer. You can simply use that, and that will Yugabyte Smart Driver is going to take care of routing the connections to all the nodes and ensuring the performance is optimal for both read and write workloads. So even when we had failures with one of the nodes, we did not notice any performance degradation or any impact to the users or anyone complaining about some issues. And lastly, I want to say, like, we made full use of Yugabyte's built-in capabilities for observability, setup, and lifecycle management, which enabled us to monitor, scale, and manage the system efficiently with minimal manual intervention. So that brings me to the end of my presentation, and thank you all for your time and attention. I hope the session gave you some valuable insights into how we approached our transformation and what's possible when you combine the right strategy with the right technology. Thank you once again, and I wish you all the great rest of the conference. Thank you.